In algebra, the concept of relation and function are significant with clear mathematical definition. A relationship signifies the link between input and output, whereas a function is a relationship where each input is associated with only one output. Relationships are essentially grouping of ordered pairs that represent connection between two sets, and they are subset of Cartesian product.
I will introduce the concept of function, the relation using a simple example. Let's start with two sets. We have set A and set B. Set A consists of the elements 1, 2, 3, and set B consists of the elements A, B, C. A function is a special type of relation where each element in set A is associated with exactly one element in set B. From the example, our function can be defined in set notation. This means the element 1 in set A is related to the element A in set B. The element 2 in set A is related to the element B in set B. The element 3 in set A is related to element C in set B. From this context, the relation from set A to set B is a subset of the Cartesian product. This means A times B. To summarize it, relation from set A to set B is any subset of A times B. A function is a specific type of relation where each element in A maps to exactly one element in B.
Next is application of relations. Our group chose about social media. Social media has transformed the way we interact, exchange information, and work together in the modern digital era. Therefore, social media platforms are now seen as an important resource for sharing information and communicating in both personal and professional settings. Social media platforms use relations to facilitate knowledge sharing. Social media platforms use various types of relations to facilitate knowledge sharing and communication. Let's break down some types of relations like following, likes, reactions, comments, and mentions. Relations in this segment are fundamental to the operation of social media platforms. They underpin the ways we connect, share information, and collaborate online. Understanding these relations help us appreciate the complex web of interaction that power our digital social lives.
On this slide, we explore the application of relation within social media platform, particularly from the perspective of discrete mathematics. For instance, consider how Instagram, WhatsApp, Twitter, and LinkedIn enable users to connect through different means. Instagram employ hashtag in discrete mathematics. This can be seen as creating an equivalent relation where posts are grouped into equivalent classes based on shared hashtag. For Twitter use mention which can be modeled as directed edges in a graph, where a mention creates a directed relationship from one user to another. WhatsApp allows messaging group forming undirected graph, where each group is a complete subgraph and connection depend on mutual group membership. And LinkedIn link user through their professional connection, which can be represented as a network graph, illustrating nodes, user, and edges, which is connection. As an example, Instagram's post and the interaction received from a complex network of relations. This network can be analyzed using graph theory, a fundamental aspect of discrete mathematics, to study properties such as connectivity, centrality, and community detection within social media platform. Discrete mathematics provide the tools to model, analyze, and understand this relationship, showcasing the intricate web of connection that define our interaction on social media.
Lastly, I will continue to explain the conclusion. In conclusion, relations and function are fundamental concepts in algebra that define how inputs and outputs are linked within sets. Relations are grouping of ordered pairs and subset of the Cartesian products, while functions are specific relations where each input has a unique output. This unique correspondence is expressed in set notation as function A to B, ensuring each element in set A pairs with exactly one element in set B. Understanding this concept is crucial for exploring more complex mathematical relationships.